All right, we are now in Unit 2. This is Lesson 2.1.1. We're going to look at linear growth. We're going to start by looking at some patterns and see if we can make equations from the patterns or equations from tables. We've played around with it a little bit, but we're going to formalize the relationships that we've kind of looked at in the last unit. Okay, so for this one, we're going to start with a pattern. Okay, so here's pattern A. This is our first pattern that we're looking at. So if you guys don't want to draw this yourself, in Google Classroom, there is a resource page that you can get to that I've added up there, and you can download and print off this pattern to work with, or you can just draw the pictures on your paper. Either one works. So anyways, we talked about last unit that when we saw these patterns, we wanted to see what was happening from pattern to pattern. Now this one starts at figure 1, and we're going to try to go back and find out what figure 0 is. We're also going to try to go forward and find out what figure 4 is. And eventually we're going to look at equations that make these patterns. Usually what I like to do when I go from pattern to pattern is I like to see what's changing between them. So I'm going to look at figure 1, and I'm going to fill in everything in figure 2 that is the parts that are figure 1. So we had, looks like 1, 2, 3, 4, 5, 6 going horizontally, and then we had a little poop right there at the end. So it looks like in figure 2, the growth is this one on this side and then 2 on this side. All right, we're going to go forward again before we start going backwards. So the previous pattern, it had 2 right here. So I'm going to go 1, 2 right here. And it had all these bottom ones done. And then it had 4 total right there. So 1, 2, 3, 4. And what are we left with? We're left with the growth. So it was growing here, and it was growing here and here. So look at what we've got so far and see if you can predict what our next pattern's going to look like. So look at the pattern of how it's been growing so far. Well, I'm going to start by just doing what was already there. So I know that I had 3 right here. So 1, 2, let's talk about these 3 right there. 3 right there, 4 in between. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6 there. So 1, 2, 3, 4, 5, and 6. All right, so that's what the previous one looked like. So how was it growing? It looks like to me that each time this top one, or sorry, this left one is growing by 1 here. So I'm going to add 1 to this side right here. And it looks like the right side is growing by 2. All right, so 1 on that side, 2 on that side. Now let's kind of go backwards. So if this was the patterns that 1 is growing here and 2 is growing on that side, what's the actual growth on this one? Well, it would have been 1 on this side and 2 on this side, which means figure 0 is what's left in the blue. So figure 0 would have been just 3 horizontal squares. 4 horizontal squares. Counting's hard. All right, so 1, 2, 3, 4. So that's what the figure 0 would have looked like. We would have had 4, and then on figure 1, we added 1 on this side and 2 on this side. On figure 2, we add 1 and 2. Figure 3, 1 and 2. Figure 4, 1 and 2. All right, so looking at that, we want to start answering some questions about this. So the first question that we want to look at is how many tiles are in figure 0? Well, figure 0 looks like 4 tiles. All right, how many tiles does it grow by each figure? Well, the growth is kind of centered around two sections. Looks like on this side it's growing by 1, and this side it's growing by 2. So that's a total of 3 tiles that is growing by each time. So it's growing by 3 each time. Now, could we predict how many tiles are in figure 100? Obviously, we're not going to draw figure 100 because that would be huge. But kind of look at it. Figure 1, I've got 1 on this side, 2 on this side. Figure 2, I've got 2 on this side, 4 on this side. Figure 3, I've got 3 on this side, 6 on this side. And figure 4, I've got 4 on this side, and on this side, I've got 8. So what is the pattern that's happening there? Well, it looks like if I had to draw it, if I had to describe what's going on here, it looks like I have the 4 in the middle, and then this side is the one that's growing by 1 each time, and this one is growing by 2 times the figure number. So if I had the 100th figure, this left-hand side should have 100 tiles in it. The right-hand side should have 200 tiles in it. And then this middle part doesn't change, and it was 4 the whole time. So if I add up those 3 sections, it looks like the figure 100 would have 304 tiles in it. So as we can see in figure 1, this side's growing by 1, this side is 1, this side's 2. In figure 2, 2, 4, 3, 6, 4, 8. So it looks like this side is the figure number, and this side is twice the figure number. So in 100 tiles, this side is the figure number 100, and this one is double the figure number 200. So we've got a total of 304 there. All right, now we need to make an equation for this one. So in our equation, we're going to make y, and y is going to be the number of tiles. And I'm going to be making x the figure number. All right, so I need some kind of equation that's going to describe that. Now remember, we're starting with 4 tiles, and it looks like each time I'm growing by 3. Come up with an equation where you think that if you plug in the figure number, you'll get the tile number. Okay, I'll give you a little bit of time to look at it. And the answer to it should have been 3x plus 4. Okay, so now I'm supposed to explain my equation. I came up with the equation of y equals 3x plus 4. Now the reason why I have the 3 is the 3 means that for every tile, I'm going to get 3 more or for every pattern, I'm going to get 3 more tiles. And the 4 is our starting number. So for each pattern, the growth is 3. That's where this 3 is coming from. And 4 represents the starting point when it was at figure 0. So when you have 0, it's 3 times 0. So you need the 4 to account for these 4 tiles that we started with. So for each pattern, the growth is 3, and it starts at 4. Sweet. All right, we are ready to move on to pattern B. All right, next one. Okay, remember our plan for these ones? Generally what we're going to do is we're going to go, okay, from here to here, let's color in blue what we started with in this one, and then we'll see how much it's growing by. So it looks like it's got this little L-shaped thing right there. So here's the L-shaped thing right here. And then it's got 1 and 1 there. So 2 diagonal ones. 2 diagonals. So it looks like the growth here is this one and this one. Okay, on the next one, okay, I've got these 3 L's, 2 diagonals, 2 diagonals. So got the L up here, 1 diagonal, 2 diagonals. All right, and what's the growth? Looks like the growth is right here. Looks like we've got the diagonals again. All right, predict what the next one will look like. I'm going to go ahead and pause it real fast. I'm going to fill in figure 0 and figure 4. See if you can also write the equation. So I'm going to pause, 3, 2, 1, and I'll be right back. All right, I'm back. So here's what mine looks like. So it looks like on this one, my figure 0 just had these 3 right here. And it looks like on my figure 4, I had the 3 starting ones, and then 2 diagonals, 2 diagonals, 2 diagonals, and then I added a second pair of diagonals there. And there's my pattern. My equation that I came up with is y equals 2x plus 3. The reason is because for every tile pattern it was growing by 2, and my figure 0 was 3. So we're going to fill out this part of our notes. How many tiles were in figure 0? There were 3 of them. How many tiles does it grow by for each figure? It looked like it was growing by 2 each time. So if I was looking for the 100th pattern here, I know that I'm starting with 3, and it looks like each figure number I'm getting 2 more of these. Each figure number, I'm just adding 2 at the end of it. And I'm just making this huge long tail. So in the 100th figure number, I should have 100 of these double tails. So one of them here, this is figure 1, I've got 1. Figure 2, I've got this one and this one, there's 2 of them. Figure 3, I've got this one, this one, this one, there's 3 of them. Figure 4, I've got this one, this one, this one, this one. So for each figure number, I'm getting 2 more of these. So it looks like if I were to describe what was going on, I'd have 3 blocks right here. Those would be my starting blocks. And then I would get 100 of those. Now, since there's 2 of those, that means I'd have 200 of those extra tails that were added every single time. But up here, these first 3 blocks, tiles, they didn't change. So I'm thinking that in my 100th figure, I should have 203 tiles in it. So I'm going to say 203. Now our equation that we wrote for that was y equals 2x plus 3. If I plug in 100 here, 2 times 100 is 200, plus 3, 203. So having the equation is really helpful. All right, the next one, our next pattern is not a tile. The next pattern is just simply an equation. So here's my equation, here's my figure numbers. We want to fill in the figure numbers for that equation. Okay, so when it's 0, remember these are the x values, so I plug it in there. 3 times 0 is 0, 0 plus 1 is 1. If I plugged in 1, I would do 3 times 1 is 3, plus 1 is 4. If I plugged in 2, 3 times 2 is 6, 6 plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 3 times 4 is 12, plus 1 is 13. All right, how much is the pattern growing by? In order to find out how it's growing by, we look at the Y values. That's the tile patterns. And it looks like we're adding 3 here. We are adding 3 here. We're adding 3 here. And we're adding 3 here. So the pattern is growing by 3. The starting value. The starting value is always when x is equal to 0, so the starting value is 1. So what's the relationship between the growth and the starting value? Well, it looks like the growth is the coefficient of the x value. So the number out front, the number that's multiplying. So it looks like this number here is the growth value, whereas this one right here is the starting value. And that's what the relationship is. The growth is the coefficient of x, and the starting number is a number that's out right here. All right, let's say that we have a friend. Your friend refuses to show you the tile pattern that they made, but they want you to guess what their 100, how many tiles their 100th pattern would have. So they're trying to trick you maybe, or they're trying to quiz you here. So they've got this pattern. They want you to find out how many tiles are in the 100th pattern. What would you guys need to know in order to predict how many tiles are in that pattern? Would you actually need to see their pattern? Or is there some other information that you could use to find out how many tiles are in the 100th? And the answer is, you would need to know how much it's growing by and what they're starting at. So you would need to know their figure 0, and you'd need to know how much it's growing by each time. So if we know what the growth is, which is the coefficient of x, and if we know what the starting number is, which is figure 0, we can find out how many tiles there would be in 100, because all we would have to do is multiply the growth by 100 and then add the starting amount to get to their 100th pattern. Without ever seeing what pattern they've drawn, we could figure it out just knowing these two things. All right, our next section, we're going to look at tile pattern D. So last pattern here for today. All right, so tile pattern D. I want you to find figure 0. I want you to find the equation. And then if you've got the note card thing, if you've printed off this notes thing, go ahead and fill in the table right there. All right, I'm going to pause it in 3, 2, 1, and I'll be back in a second. So pause it and do it yourself. All right, so here we have it done. You can see here that figure 0 just has a single tile, whereas this figure over here, we've got a total of, looks like 17 tiles. And you can see out here, the way that I've colored it, that you can see that the growth is at the end of each of these, I don't know, arms or whatever you call them. They're always adding 1 tile to the end of the arms, so that they're adding 4 tiles each time. So I wrote the equation, 4x plus 1. Our initial value is 1, and we're adding 4 tiles each time. So 4 times the figure number plus 1 would be the answer that works. And you can double check your answers. In the fourth figure, you would put 4 times 4 is 16 plus 1, and you would get 17 tiles, just like we have right here. So in figure 0, 1, Add 4, we get 5. Add 4, we get 9. Add 4, we get 13. Add 4, we get 17. So there is our pattern D. The last question that we have is, what are the similarities and differences between these two patterns? So we had pattern C and pattern D. So how are they the same and how are they different? So what do you notice that's the same? So looking through these two numbers, here's what I notice. I notice that figure 0 is the exact same thing. They have the same exact starting value. So I'm going to write that they have the same starting value. All right, so what is different between them? Well, after the first tile, this one is 4, this one's 5, so that's 1 more. This is 2 more, that's 3 more, that's 4 more. It looks like they have different growth rates. So I'm going to say, but different growth rates. And look at their two equations. For instance, this one had the equation of 3x plus 1, and this one had the equation of 4x plus 1. So here we can see that their starting value of plus 1 is the same, but their growth value of pattern C was 3, and the growth value of pattern D was 4. So that's where they started differing. So that's why after pattern 0, the numbers were no longer the same. All right, you are ready to do some homework. Enjoy. Thanks for watching. Bye-bye.